In Nebraska, a dam goes up against Mother Nature and loses.
There was chunks of ice out here.
It looked like somebody had set off a bomb.
Tragedy in Germany as an Alpine ice rink collapses in seconds.
Oh, stop, no, my wife is there inside.
In Tennessee, a toxic wave washes through a community.
And all of a sudden you see this stuff coming towards you. You had very little time to escape.
And in Canada, one of the world's biggest bridges crashes to earth.
It was a huge mess of steel. Everyone lost someone.
With big builds, even the smallest fail can trigger a huge disaster. From miscalculations to misunderstandings, or just plain bad luck. These catastrophes are every engineer's worst nightmare. When building big, engineers often try to harness the elements. But sometimes Mother Nature refuses to be tamed. Like this disaster in Nebraska, as a flood tore through America's heartland.
Hillside, it was all gone. It's like you only see it in movies.
A dam that was no match for the unstoppable power of water.
You could hear it. Sounded like a freight train going down the road.
This disaster cut off a community from the outside world.
There was chunks of ice out here big as boulders.
Nebraska sits squarely in the middle of the Great Plains, where the vast flat landscape is sliced in two by the Niobrara River.
Niobrara comes from an indigenous word which translates as wide-spreading waters, and it lives up to its name, running wide and swift, eastward toward the Missouri River.
Thanks to the river, the sprawling plains are perfect for grazing cattle. Paul Allen runs a ranch near the small town of Lynch.
It's my kind of country. You come by the closest neighbor up here 3 miles. My dad always told me, no matter where you go to raise cattle, you gotta have water. And I got the Niobrara River.
Since 1927, ranchers here have shared the river with a hydroelectric dam, a few kilometers upstream from Lynch. As engineering professor David Admiral explains, this wasn't a traditional gravity dam.
Well, there's various types of hydroelectric dams, but most of them work with the principle of impounding water upstream, and then that water is run through turbines. The turbines generate electricity.
Many dams impound water by blocking a natural gorge, using gravity to power their turbines. But in Nebraska's flat landscape, a deep reservoir wasn't an option. Instead, engineers harnessed the Niobrara River's swift flow.
Well, the Spencer Dam is a run-of-the-river dam. Run-of-the-rivers don't have very much water in them, and so the water quickly passes through the reservoir and goes to the outlet.
Instead of dropping water from high up to generate power, here, the turbines are driven by momentum from the fast-flowing river.
The river flows, according to the guys that know that stuff, at 7 miles an hour about. When there was high water and there was ice chunks, it was going darn close to 10.
All that was needed here to manage the fast flow was a relatively low embankment dam.
Embankment dams are simple and cheap to build, using mostly local materials, which makes them perfect for remote locations.
But by 2017, the power output of the 90-year-old dam was outstripped by the cost to maintain it. Authorities decided to decommission the structure. But before they got started, Mother Nature stepped in. March 13, 2019, Winter Storm Ulma, a so-called bomb cyclone, was ravaging the Midwest with heavy snowfall. Sheriff Chuck Reed was out rescuing trapped residents.
I've been doing this job since 1976, and I have never seen anything like that. I've been through some snowstorms that it'll snow and maybe get 3-4 foot of snow in a night, but nothing like this.
Upstream from Lynch, the bomb cyclone was causing ice to break up on a massive scale, triggering major flooding.
First time that I've lived here in my entire life that the river come over the riverbanks. Even in the winter, it never, in my lifetime, never come over.
At midnight, 2 dam workers were monitoring the flow from upstream. They were expecting floodwaters and fully opened all the gates.
But it wasn't just water traveling their way. Fire Chief Jim McBride saw massive ice blocks heading for the dam.
Happened to see those ice chunks, and we never dreamt they were as big as they were.
The ice chips that floated down were anywhere from 2 to 3 foot thick, and they were the size of a pickup truck or a small tractor.
Ice and water piled up against Spencer Dam. Workers needed to open floodgates on the far side of the river.
There was a walkway on top of the dam, but the conditions made it too dangerous to cross. So the workers headed out by road, planning to cross the river using a bridge downstream.
It's a decision that saved their lives. In the early hours of March the 14th, the dam gave way.
Dispatch called me and said the Spencer Dam has been compromised. And we were like, that's not good.
Jim and Chuck went to check on the situation, but the raging storm obscured everything.
When we first got here, you could hear it. Sounded like a freight train going down the road. But all you could see was snow.
By dawn, it was clear the embankment dam had been wiped out.
It looked like somebody had set off a bomb in there. And the hillside, it was all gone. It's like you only see it in movies.
The ice ended at about where them 3 last trees are there. And then from there, it just got progressively deeper.
Tragically, one resident downstream had perished in the floods, and vast sections of the community were cut off.
We lost every bridge except for one, which is on the east end of this county. So the only way to get from here to the south was about 57 miles. If you went to the west, it was a 150-mile round trip. So it was quite a task.
Isolated locals pulled together, and Lynch Fire Station became a communal dining hall.
The community hall, the public ate in there, and with the bridges and everything, we brought in porta potties for everybody to use, and it's cold out, so it wasn't fun doing this. It was months before we got used to things.
As the community struggled to regain some sense of normality, investigators wanted to know what had caused the dam to fail. There were no witnesses to the moment of the collapse, but engineers found a clue in the remains of the powerhouse.
The ice had smashed a hole in the back of the building, allowing water to flood in, and marks on the wall showed that it reached the height of the dam's crest.
The obvious conclusion was that water had flowed over the embankment, which is known as overtopping, and can be fatal for this type of dam.
Professor of Engineering David Admiral explains.
For earthen dams, it is particularly dangerous because earthen dams are erodible. And once water starts flowing over the top of the dam, it starts to carry away sediment with it, especially where the water picks up higher velocities. And once it starts to pull that sediment away, it creates a bigger and bigger channel. The velocities get higher, and it just gets worse and worse.
But this dam was designed to let the river flow. So why had the water gone over the top? Investigators deduced that the ice played a key role, as David demonstrates. with wooden chips acting as ice.
And we see the flood starting to rise upstream. And it comes in pretty quick. It's going to start lifting the ice. And the ice starts to move, and it all jams up against the dam. Then the ice is going to cause the flow to rise up behind the dam more than it would usually. And the water will actually overtop the dam. And there it goes. What we saw here was just a relatively small amount of ice. But if you imagine in the real situation, there would have been ice coming and coming and coming for a long period of time.
The dam had already been scheduled for demolition. But with the massive amounts of ice, Mother Nature just accelerated the process. After nearly a century, the river now runs wild again. And for the community around Lynch, their spirit too remains unbroken.
It's life. You fall off, you just get back up and get back on.
This hit the county real hard, and we've come back better and stronger.
In big engineering, every piece, no matter how small, has a critical role to play. If there's any flaw, the results can be catastrophic. Like this disaster in Germany. A frozen nightmare at an Alpine skating rink.
Lots of people injured, people leaving their lives there in a tragic rescue operation.
An engineering fail that triggered a race against time to save those trapped in the icy wreckage.
No, stop, no, my wife is there inside.
In Bavaria, southern Germany, lies the ancient town of Bad Reichenhall. Now a tourist destination, it was once a centre for salt mining.
For centuries, this town was the country's most famous salt producer. But more recently, it reinvented itself as a spa town and ski resort, thanks largely to an abundance of winter snow.
In the early 1970s, the region's reinvention included this sports venue, complete with an indoor ice skating rink, all protected from the elements by a vast roof, topped by a weatherproof membrane, resting on a wooden box girder frame.
Wood is a popular choice for ice rinks for multiple reasons. It naturally insulates against the cold, it helps dampen noise from the people below, and it can absorb and release water vapor from the damp atmosphere.
Engineering professors Philip Deitch and Stefan Winter are specialists in timber structures.
It was constructed 1971-72, and it was a very novel type of structure that had not been constructed before.
Because a box girder is quite a lightweight structure. In the middle there is no materials.
The main girders were connected by secondary elements, K-bracings, which then carried load between the main girders, but also restrained the main girders from buckling, so from moving horizontally.
At the time, the design pushed the limits of technology and timber construction.
This was incredibly wide for a wooden structure. The girders had to be made in 3 sections, each 50 feet or 16 meters long, then connected with finger joints and a strong adhesive known as urea formaldehyde.
For more than 30 years, the pioneering roof faithfully sheltered the skaters below. But a creeping weakness was about to be tragically revealed. January the 2nd, 2006. Heavy snow on New Year's Day had settled on the roof of the hall.
Around 30 centimeters of snow was recorded in just a few hours. But although clubs had canceled their ice hockey training, the rink was still open to the public.
Around 2 p.m., Robert Schromm's wife and 5-year-old daughter were enjoying an afternoon trip to the ice rink.
It was a Christmas present, and that was the first time for my daughter to be in an ice hall. It was the first day in her life to be on ice skates.
Shortly before the rink was scheduled to close, Robert's daughter was doing one last lap when disaster struck. The roof had come crashing down onto the rink below. Robert received a call that something was wrong and raced to the scene.
There was a lot of police and the road was closed and we're running and no, stop, no, my wife is there inside.
33 people were trapped under the wreckage. Robert's wife and young daughter Ricarda among them.
Every second was a catastrophe itself. A second is something like a life.
With people trapped under mountains of debris, the clock was ticking. Hundreds of first responders from Germany and nearby Austria rushed to help. Emergency search and rescue volunteer Thomas Wellenhofer was on the team.
It was challenging, it was hard. The whole area was covered with heavy snow. Don't see what's beneath it. Is there a person laying down? All those things are problematic.
While first responders were trying to free those trapped, their own safety was becoming increasingly uncertain.
This unstable structure had the potential to collapse again at any moment.
The rescue operation was quickly becoming a race against time.
With no sign of Robert's wife and child, all hope was slipping away.
You have to imagine what a minute in this situation means. There was nothing. For a long, long time, nothing. And then I thought, okay, I think there's no more chance.
As conditions deteriorated, rescue workers were forced to pull back.
We were concerned, so we closed down the whole area immediately.
But just as they were leaving, one of the search and rescue dogs began barking.
This dog made some noise and then they say, come, we cannot go. A friend of mine was just running to me, shouting, Ricarda was found. Ricarda was found. Really? Ricarda was found? Really?
Miraculously, after more than 6 hours trapped in the freezing wreckage, Robert's 5-year-old daughter was still alive and was rushed to the hospital.
My daughter there, at this moment, she was protected and I had a strong desire to go back to my wife. And then I traveled back to Reichenhall and waiting the rest of the night and the rest of the day and so on.
Hundreds of rescue and emergency workers, volunteers, and even the army worked tirelessly for more than 3 days to get every last person out.
But despite the superhuman efforts, 5-year-old Ricarda was the last person to be recovered alive. Of the 33 people trapped under the roof when it collapsed, 15 lost their lives. Tragically, Robert's wife Michaela was among them.
Germany has a reputation that this is a safe country, and in this case of Reichenhall, I had to realize that all these things in this case are not true.
The disaster shocked the entire nation, and the calls for action reached the highest levels of government. Initial speculation pointed at the heavy snowfall that had accumulated on the wooden box girder roof. Professors Philip Deitch and Stefan Winter were on the investigation team.
In the news, all people said, well, there were heavy snow loads and that is the reason. There was a lot of snow, but our measurement showed that it was exactly what normally the structure should have taken.
The roof had withstood heavy snows for more than 3 decades. So why had it failed now?
All the pieces, like a puzzle, were placed to enable us to really look at some of the details.
Engineers examined the roof piece by piece, trying to figure out exactly what had gone wrong. And then they found the answer.
The problem lay where the sections of the giant box girders were connected using so-called finger joints, all bonded together with a glue known as urea formaldehyde.
This type of adhesive works well in a dry environment, but crucially, it's not permanently moisture-proof. So in an unheated ice rink with a damp atmosphere, the bond from the glue was getting weaker and weaker.
We then have the effect of the humidity in the ice rink changing between summer and winter. Summer dry, winter wet, summer dry, winter wet. And that had an effect on the finger joints, on the glues, which then gradually lost their strength.
Although the timber itself had stood up well to the decades of fluctuating humidity and temperatures, the glue had deteriorated over time.
Add in 30 years of gravity pushing down from above, and high up in the wooden roof, the finger joints were slowly losing their grip. The heavy snowfall on New Year's Day was the final straw. And once one beam broke, it caused a domino effect, until the entire roof came crashing down.
These crucial load-bearing connections just couldn't hold on any longer.
And you can see that the next one, the next one, the next one, the next one.
That eventually led to the progressive collapse of all 12 beams coming down within, we guessed, 15 seconds.
Following the disaster, attention quickly turned to other wide-span structures across the country.
The collapse led to immediate inspections of hundreds of other buildings, which uncovered a number of defects.
As a result of their investigation, Stefan and his colleagues created a checklist. Guidelines for all engineers to follow on any subsequent inspection of a wide-span structure. And not just timber.
One of the main lessons learned is that we need regular inspections of those buildings, and that these inspections need to be what we call hands-on. If you can touch it, then you're close enough.
In 2007, the rink was demolished. A memorial now stands in its place to honor the victims of that terrible day.
This tragedy was felt by the whole nation. And the hope is that the lessons learned by engineers will prevent something like this from ever happening again.
With big engineering, every project demands attention to detail. But sometimes a problem can lurk undiscovered until it's too late. Like this disaster in rural Tennessee that unleashed a destructive toxic flood.
All of a sudden you see the stuff coming towards you. You had very little time to escape.
An unstoppable wave that tore through the heart of a community.
The force behind it was just something you could never imagine. It was just so powerful.
An unforeseen problem with devastating consequences.
This was by far the largest industrial spill in U.S. history.
East Tennessee, 1943. Under a cloak of secrecy, a small community emerged, named Oak Ridge.
The town of Oak Ridge didn't appear on any maps, and yet it played a central role in a massive effort to end World War II, the Manhattan Project.
Journalist Jamie Satterfield explains.
The Manhattan Project was where, in secret, the uranium enrichment process was carried out that was necessary to construct the nuclear bomb.
Despite having a staff of thousands, no one outside the project knew of the facility's existence.
It wasn't some place that had folks that visited. It was easy to be secret in Oak Ridge.
After the bomb destructively brought World War II to an end, scientists began looking into more peaceful uses for nuclear technology.
Nuclear research takes massive amounts of energy, but this was long before nuclear power was even possible. So ironically, the necessary power source came from burning fossil fuels.
In 1955, this massive coal-fired power plant came online, just down the road from Oak Ridge.
When it was built in the 1950s, it was at that time the largest coal-fired plant in America.
The plant can burn 10,000 tons of coal a day, producing a vast pile of waste ash, otherwise known as tailings. Mike Cambridge is a civil engineer.
In the case of the thermal power industry, for every ton of coal burnt, some 400 kilograms of waste is produced.
Coal ash isn't just waste carbon. It also contains heavy metals and other toxins. So for decades, power plants have had to collect this material instead of allowing it to escape into the environment.
Because they are burning tons and tons and tons of coal. It's a lot of ash, a lot. And so they also had to come up with ways to store it.
This plant, like many others, uses tailings ponds or lagoons to store its waste. Once the ponds are full, they are sealed off with a layer of grass. But when in use, they have a very different appearance.
Imagine a mud hole, right? You got the dirt and it's got some water in it, it's all kind of muddy.
When the waste products are produced from the process plant or power station, they come in a slurry form and as such are unstable and therefore need to be placed in some form of secure containment such that they no longer pose a safety or stability concern.
Step 1 was to build a more than 15-metre tall embankment dam around the planned disposal site. The tailings would fill the pond, forming a layer of ash. Once full, a smaller dam was built above and behind the original, and the process repeated itself, with the tailings building up layer upon layer. Over the decades, the pile of waste on the edge of town, beside the Emery River, grew taller and taller.
A lot of people would refer to that as the ball field. It looked like a massive football field. It was fairly flat on top. Parts of it would be grass covered.
But this well-known local landmark hid a dangerous flaw that would spell disaster for the entire region. December 21st, 2008. The holiday season was in full swing. But in Kingston, 911 calls were flooding the emergency switchboard. Investigative journalist Jamie Satterfield covered the story.
The 911 center started being lit up by people who could hear this incredible roar.
The roar was the sound of the tailings pond dam failing. At 1 a.m. December the 22nd, the dam wall collapsed, sending catastrophic quantities of coal ash down the river and into Kingston.
And all of a sudden you see the stuff coming towards you. You had very little time to escape, and because it was covering up the roads, you didn't even have access to be able to escape.
Holly Sheen was racing home to check on her father.
The force behind it was just something you could never imagine. It was just so powerful. I was terrified. I had no idea what was going on, if my father was okay, or even the condition of our home.
The flood of coal ash sprawled across more than 120 hectares, burying dozens of homes.
There was just tons and tons of gray muck that was moving. Hours after the spill, moving and knocking houses off their foundation, covering the roads, going into the water. It was wild.
When the ash settled, the surrounding area had been transformed.
The morning after the spill, it was like it was sitting on top of the moon because there was gray all over the place. It's just gray material covering everything.
The home that Holly Sheen shared with her father had been buried.
So all of this was covered with ash. Our house and the road and everything was covered.
In a miraculous rescue, first responders had pulled Holly's father to safety.
We're all crying and worried, and he's just like, no, you know, it's no worries, I'm here. My dad, he was a tough guy.
To the shock and relief of locals, at the time, not a single person was seriously hurt. This disaster was the largest industrial spill in US history. More than 4 billion litres of coal waste had flooded the area, and the race was on to clean up the toxic mess.
They were summoning all these workers to come and get on heavy equipment and start trying to push it back.
Hundreds of workers painstakingly removed the coal ash. The first stage of the cleanup took almost a year.
With this much toxic sludge in the environment, the only option was to literally dig, pump and scrape it all from the land and the river, then ship it away for disposal.
Although no one knew it then, cleanup workers were being exposed to toxins trapped in the ash. The true personal cost only became clear well after the initial cleanup was complete.
Probably a year of the spill, strange things started happening to the workers. They started having this problem with this low testosterone, and we've got these skin things, and they start describing these symptoms.
This wasn't just an environmental disaster. The impact of the cleanup on the workers was horrific. And it's always been a hugely controversial subject, with litigation continuing to this day.
Workers were unaware of the toxin exposure at the time, and so the cleanup effort continued. While officials raced to investigate what caused the spill, the problem was obvious. The dam wall surrounding the tailings pond had failed. The question was why?
That breach can be caused by instability, by seismic action, by loss of flood control, and overflowing of the dam itself.
Engineers determined that an instability in the embankment caused it to slip sideways. And the reason was a surprise to everyone.
Investigators took samples from the tailings, and they discovered that there was more to this ash than they had expected. When saturated with water, incredibly fine powdered ash had formed a slime-like layer.
This stuff is real mucky and slick, and something happened that caused it to kind of shift.
Sealed off from the world above, the slime was deep within the pile of tailings. The slippery substance caused the layers of ash to slide, exerting pressure on the embankment until the dam catastrophically failed.
Over the years, the ash had slid sideways by more than 20 meters, putting extra strain on the embankment that engineers had never anticipated.
Now that the cause was established, it was crucial to get the power plant back online. This time, the rebuilt tailings ponds would be closely monitored for movement, whatever the reason.
So, especially after the spill, they did some redesigning of how they stored coal ash. Monitors were all over this site. And those are meters that check for the stability of what's going on underground.
In 2015, new rules were implemented for the safe storage of coal ash.
Regular inspection and monitoring and third-party reporting ensure that should anything occur, it is being corrected before it can actually turn into a breach.
And although Kingston continues to recover, many residents like Holly Sheen have rebuilt their lives away from the coal plant.
I have passed this area every single day since it happened. It's a beautiful area. It'll always be beautiful no matter, the memories.
With everything they build, engineers check and double-check every detail. Miss one thing, and the results could be catastrophic. Like this story in Quebec. A construction tragedy that left a nation reeling.
In Quebec City, people thought that there had been an earthquake.
As one of the world's biggest bridges came crashing down.
Et tout ce qui avait été construit s'est écroulé comme un château de cartes.
It was a huge mess of steel in the water.
The consequences of this catastrophe echoed around the world.
This disaster changed bridge engineering forever.
Quebec City thrives thanks to the St. Lawrence River, a vital trade route connecting the city with both the Canadian interior and the rest of the world.
The Algonquin people named this area Quebec, meaning where the river narrows. It was the perfect location for a city to thrive, with boats carrying people and cargo up, down, and across the river.
All that changed in 1919 with the opening of the immense Quebec Bridge, which was crucial to the city and Canada's success.
This bridge created a permanent year-round route for trade between Quebec and the United States. And importantly, it could be carried in vast quantities by rail.
Planning had begun in the late 1800s. The challenge to design a bridge that could carry the heavy load of a train 45 meters above the shipping channel, across a span of almost half a kilometer. Frank Griggs Jr. is a civil engineer.
For long spans, only two options were suspension bridges and cantilever bridges. A suspension bridge on a long span, right, has a tendency to be a little bit too squishy. They're looking for something a little more rigid. Therefore, they went to a cantilever bridge.
Then as now, this was the longest cantilever span in the world. But this mammoth structure isn't the Quebec Bridge engineers originally built. A decade before this was completed, its predecessor met a tragic end. 1905, on the south shore of the St. Lawrence River, the first Quebec Bridge was taking shape. Although more slender than the current crossing, both would be made from vast pieces of steel, every one of them bolted together by hand.
At the time, this was one of the biggest infrastructure projects in the world, with a team of about 100 ironworkers who came from far and wide to build the bridge.
Working with massive pieces of steel high above the river was dangerous and demanded huge amounts of bravery and expertise.
38 of the ironworkers came from the Gunnawake Mohawk community near Montreal. Barbara Daibo's great-grandfather Louis was one of them.
The Mohawk men were really valued for their fearlessness, for their skills. They were really, really good ironworkers.
By June 1907, the bridge was steadily growing across the river, with the workers manually bolting it together, piece by piece.
To get such a big job that would last many years and provide income for his family, that was a great opportunity.
But as the team toiled, they realized the structure was experiencing serious problems.
Engineers noticed that some of the steel members that were resisting the load from above or under compression were starting to deflect or bend.
These 17-meter-long steel members, known as cords, supported the entire weight of the bridge above. Senior engineers urgently discussed what to do, but construction was allowed to continue. By late August, the ironworkers were high above the middle of the river. Michel Lebrun is a historian.
Le 29 août 1907, alors qu'il y avait une centaine d'ouvriers sur la structure, il restait 20 minutes à faire pour terminer la journée de travail. Et là, on a entendu un craquement épouvantable et tout ce qui avait été construit du pont s'est écroulé comme un château de cartes.
Thousands of tons of steel had fallen to the banks and the river below, along with the workers.
Ça a fait un bruit terrible qui a été entendu des milles à la ronde. Alors, les gens, au départ, pensaient que c'était un tremblement de terre. Mais là, la nouvelle s'est répandue que c'est le pont de Québec qui venait de tomber.
In the following days, the true scale of the disaster became clear. Of the 86 men working on the span, tragically 75 lost their lives. 33 of them from the Kahnawake Mohawk village.
And this one's my great-grandfather, Louis Sadeyoguiris Daibust, 36 years old. Everyone lost someone. You could just imagine the grief, the disbelief, the what do we do?
News of the disaster spread around the world. Just 2 days later, a royal commission was established to investigate the tragedy, and engineers headed to the site.
The commissioners spent 6 months analyzing the wreckage, speaking to eyewitnesses and the bridge engineers, trying to establish exactly what had gone wrong.
It turned out that during the design phase, there had been a change of plan.
The change was made to move the bridge foundations closer to the riverbanks, which had two main benefits. In shallow water, they would be easier to build, and they would be better protected from the ice flows coming down the middle of the river.
But this also meant the central span would grow from around 490 to near 550 meters. And with the increase in length came an increase in the weight of the structure, which only came to light during construction. Frank Griggs Jr. explains.
They originally designed it dead weight for a 1,600-foot central span. They built the entire anchor arm on the assumption of a lower weight. Now, as they started to get onto the cantilever arm, they found out it coming in heavy.
In fact, the bridge weighed almost 20% more than anticipated. The extra load on the lower chords explained why they had been deforming.
Compression may push on it too much, it'll buckle rapidly, catastrophically, and that's what happened here. It only takes one member to fail, and this whole thing comes tumbling down.
6 months after the collapse, the Commission delivered its report, which clearly found that the lower chords, as designed, were too weak to do their job.
The investigators determined that the bridge was already doomed to fail 2 days before the tragedy. And from that point on, nothing could have been done to prevent the collapse.
The human cost had been enormous, but a bridge here was seen as critical to Canada's economic success. So in 1911, 4 years after the collapse, construction began on a replacement.
C'est le gouvernement fédéral qui a repris la construction d'un deuxième pont. On a changé le plan du pont et cette fois-ci, les calculs avaient été faits en fonction d'une ouverture de 1800 pieds.
By September 1916, the two massive cantilevers were complete, and it was time to lift the more than 5,000-ton central span.
The central span was being hoisted up bit by bit, but when it was only a few feet or meters up, there was a cracking sound. And the entire structure twisted and then crashed into the river below.
13 workers died in this collapse, which was due to a broken casting, and left the rest of the bridge undamaged.
To have such a huge construction project fail, not just once, but twice, was a major tragedy for the industry and for the nation, and a terrible reminder of the dangers inherent in massive engineering.
Finally, in September 1917, a decade after the first tragedy, workers successfully hoisted the final piece into place, where it still stands today as a monument to the 88 people who died, creating Canada's most important crossing.
But it gave our men and women now that do ironwork more strength and more drive to keep going and carrying on that legacy, saying that we just didn't die there.